everybody. I hope you could sleep well. I will try to make this half demo, half hands-on about the Raspberry and be a Smalltalk. The idea was like we detected like there were quite some folks interested on this area, and the other half were like they didn't know what that was, or they never tried to experiment. So the idea is, why don't we make this workshop so that we can leverage a little bit, and those that have never had any experience try to get home with a working example. So first we will need to give this. Instantiations give us 1 pi to each of us. So if you don't mind, I will pass the box around and you will each take one. You will see here are the pies. You will see here a number. That's your host name. Okay? So if you want to follow the workshop, don't swap the box or the pies with your partner, because you will try to access another pie. Okay? So here are the pies, and here is the power supply. So take one of these and one of these. Okay? Start here.
Oh my gosh,
Push.
I'm the tester. Okay, so
Yeah.
there's an extra box in there. What about this extra box?
Well,
We've been given no instruction on that.
I can probably facilitate.
No, I want to do this. One of these, no swapping. I'm going to hand because I've got the box in my lap. There you go, one. No swapping.
Okay.
No swapping.
Thank you, Instantiations.
Yes, thank you, Instantiations.
What is this?
what is this?
You got an empty box.
Okay.
Yeah, it'll come back.
I will come back.
Because I'm not going to follow. Well, I'm gonna
I will bring you on.
Don't worry, don't worry.
Okay.
Like apple crisp.
I gave him mine.
Vanilla ice cream on my phone.
So the folks started asking, okay, what it is? What it is a Raspberry Pi? And the easiest thing to say about that it's just a computer. It looks small, but it's a computer. You can run normal programs. You can run Linux on that machine. You have 40 pins, which allows you to do in I/O with different kind of sensors of whatever you would like to connect to the Pi. So this has become quite famous in the area of IoT, Internet of Things, where you could have something that you want to connect and take some sensor, some data, and send it somewhere. So that's basically it. It's a machine that can run Linux or other stuff, very cheap. There are many more. Raspberry Pi is not the only one. There are others. Raspberry Pi, you have Arduino, you name it. There are plenty. Each day there is a new one. Yeah, BeagleBone. So I will wait until everybody has the Pi in your hands, so you can see. Here is a diagram of what you have in your hands. So basically, it's powered by a ARM processor, which is kind of slow. I mean, this is the slowest Pi. It's called Pi 0 wireless because it has Bluetooth somewhere. It has Bluetooth and Wi-Fi. I don't think it's written there. No, it's not written. But anyway, it has Wi-Fi and Bluetooth. It has 500 megabytes, one core of at 1 gigahertz processor. So it's kind of small. It's the smallest they sell. Still, you have a micro USB for data, the power, HDMI for video, and the micro SD card, which on this type of devices, the micro SD is the hard disk. That like what would be on a normal computer. And finally, the headers. You can see here this row of pins. Those are the 40 pins where you can plug stuff and connect to the outside world. For example, this is the Pi 3 Model B, which I have it here. If you want to quickly look, it's slightly bigger, a bit more bulky. You can see it has more, yeah. But it's the main difference, I believe, is not the ports and sector, but it has a quad core CPU and 1 gigabyte of RAM and slightly more powerful cores. So it's quite a difference with the Pi Zero. So the previous one was $10. This one is $35. So you can get a machine with all these specs with $35. Well, but you, of course, for us it was like 70 because you need to buy the power supply, the micro SD. So it was not that cheap for us. But yeah, you need to add a couple more things. But as what it is, the board is as ridiculous as that. Okay, so just this is a personal opinion of why I believe it got, because I said there are plenty of boards. Every day there's a new one. So why I think it got success? Well, the reason is that I think they're really small. You can see it by yourself. They are cheap. I already talked about the prices. They are power enough to write Linux, and I think that was a game changer. Once you were able to run Linux, then boom, suddenly you can do a lot of stuff. The pins with all the ability to connect to sensors or whatever, and well, obviously the IoT popularity that it's a hot topic these days, and it's increasing and increasing. So that's just my personal opinion of why the Raspberry Pi is growing. Okay, so that's all what I wanted to show as for the slides. The next part, I will mostly first show you some things, and on the second part, it's a hands-on tutorial. I mean, if you want to follow me, then great, and I will be there to help you. My idea is that you could go home with a working Pi. So we can, there are people more experienced, so if many have issues, we can help each other.
What is with those who have working Pis at home?
What?
She'll just make it
So
better.
you help the other.
Okay.
Exactly. You help the other that won't.
Learning Smalltalk makes you a better programmer. Taking this workshop will make you better with your Pi.
Okay. So
You tell the right guy.
Let me see. Okay, cool. Okay. So, what you can see here, I'm now connecting the Pi to the projector. Okay, so I just boot it. I have here attached a hub, USB hub, and I have my mouse. And this is not my keyboard. This is borrowed. So basically, I don't want to show you that much, but you can see it's typical Linux look and like. You can do whatever you want while you don't see that much because of the you can see. I will zoom this. Okay, you can see actually this is a special Raspbian Linux which they developed especially for the Pi, and it's called Raspbian. So this operation system I am running now on the Pi on my microSD is a Raspbian OS. You can see there's not much of a difference. It's like an Ubuntu slightly prepared for Raspberry. Sorry?
For Linux people, it's Debian and Jesse is the base, and then they took a combination of GNOME and MME in terms of the top thing, and then they've got some other custom stuff for the window manager and things. It's a very nicely done thing, but it uses all the standard Debian style dev update.
Yeah, exactly.
Stuff to keep it the same.
Is it,
If you know Debian at all, it's completely familiar.
Which is like Ubuntu.
yeah.
Exactly.
Yeah, I you install whatever. In fact,
If you've used Ubuntu Mate, and actually there's a version of Mate that'll boot on this too.
yeah. In fact, I think you can write plain Ubuntu also.
Yeah,
Right?
there's a version of Mate.
Yeah, because the only thing that needs to happen is that it needs to be ARM compiled. So you need to get a distro, which is ARM compiled, and depending on the Pi, it may need to be 32 bits because
If you want to run Ubuntu instead of Raspbian, the Ubuntu Mate image for this is on the Raspberry site. They offer it as an alternative image. It just doesn't have all the apps on it.
Is it part of Noobs?
Well, now,
I mean, is it one of the packages that
you can go to that page if you want to do, maybe you actually have to download it and burn it yourself.
Yeah.
It's just a bootstrap unit.
That's what I mean, but we'll bootstrap into that as well.
yeah, I will show later how to bootstrap from Boost, so that noobs, so that the okay. So this is a normal Linux. You can install packages. Of course, Raspbian has a specific repository. So it may happen that the package that you want to install is not on the Raspbian repository, because remember that it needs to be ARM compiled. So not everything that exists and available on apt-get in Ubuntu will be here, but most of the tools are here. Now, I don't have much to show. You can see I am connected to a router that we have down there. It's so we are in our own network. That's all. Bluetooth, I'm not connected to anything. I have VNC enabled. We will later connect to VNC. Okay, so that's the first part that I wanted to show you. Just you can see I boot from here, and you see it. The same way you can boot it with a screen at your home, keyboard and a mouse. Okay, now I said that there are many different possible operation systems. Um, let me put this. So basically, there are two ways for you to install a new operation system. You can either do like a native installation where you install, let's say, Raspbian directly into the SD. And another alternative is use this thing, which it is called noobs. Sorry, but I think there's no way I can make it bigger. This is too low level tool. What this is like, whenever if you were to start from scratch, they say, because in this case it's everything prepared for you, so that everything is ready. But if you were to start from scratch, you get the Raspberry, you buy a SD, and then what you do? So you can install Raspbian if you want directly on the SD, which I think it's slightly more complicated, or this alternative, which is called noobs. To do this, you just download a zip on your machine. You download a zip. You format your SD with FAT16 or FAT32, or should be FAT. And then you uncompress the zip of noobs. You move all that into the SD, and then you boot. And then you will boot this. This is exactly, I just changed my SD card. You probably saw me. I changed the SD card where I have Raspbian, and I changed to this one where I have noobs. It just, I put the card on my machine, I download noobs, uncompress, move the files, and boot. So this card is empty. It just has noobs. From here, you can see that the download that I did of noobs allows me to install just Raspbian or LibreELEC, which is another operation system. Okay, so all I have to do is just click here, install, and that will install Raspbian on this SD. Now, if I connect to the internet and I put my password, etc., and I'm not sure I can. Oh yeah, maybe yes. Smalltalk. No. Camp. Smalltalk. I don't know if I tap it correctly. Let me see. Voila. You see now that he got internet, he says, okay, I also know about all these other operation systems that I can install as well. For example, I use a lot, this one is Raspbian Lite. So this is a headless Raspbian, no X, no with the management, no web browser, no LibreOffice, nothing. It's just a more kernel Linux headless. And I use this, for example, to deploy a CSI application on the Pi, and I was using a 4 gigs micro SD for that. And I have like 2 gigs left. So that was amazing. If you are going to something production, really, it's nice not being running the window manager all the time, because that takes CPU consumption. So I think it's nice if you're really going into production, and you don't need the X, just started manually, and the eventual need of needing that. And okay, there are much more operation system like this one. This like are like the official that can with noobs, but there are plenty. There are plenty. It's very common. Some people make their own flavor. Anyway, that's enough for what I wanted to show. I won't put it to install now because it will take like half an hour. Okay, so questions so far? Great. So let's boot your Pi. So, well, those that want to follow me, I mean, you are not required, but those who want to follow, I will do exactly like you would do. I sent a reminder last night that you should get some SSH clients, maybe VNC, because as you can imagine, I don't have a screen for each of you. So,
But it is SSHD running, right?
sorry?
There's a daemon running.
Yes, yes, exactly. So that thing written on the bag, that's your host name, and the Pi is already configured to connect to that network I showed before, which is running there. So we will all be connecting to the same network. So that's why you don't need to specify anything, and if everything works, you should be able to ping an SSH and VNC that. Let me put mine.
And then first you have to go to that network, right?
No, it's already set up.
No.
Ah, yes, good point. So from your machine, good point, thank you. From your machine, you need to go to that network so that you can connect to the Pi. Bast on Raspi.
What's the
Password. Capital S, Smalltalk, and Smalltalk. No, sorry. Camp, Smalltalk, NA, like the Twitter. Camp, Smalltalk, NA. Capital C, Camp. Capital S, Smalltalk, and that's the password. Camp, Smalltalk, NA.
works?
No problem. I will connect mine so that I can help you better.
Oh, I thought you were using ran out of bucks.
No.
Just run the.
Yeah, I'll call.
So normally I have.
Able to connect, host does not exist.
Sorry. Ping, camp, st. I 0.
If you're on Windows, you can try ping-4 and then the host.
He's asking me for an
Well, we
ACK
need-
pin for the router.
No.
So.
Okay.
Oh,
Yeah.
Okay, you're the man. I'm gonna get a second raptor.
Probably you have to disconnect the other.
So I left, right?
got some extra.
Couldn't find the music thing. Do we need to disconnect from the other Wi-Fi?
Yeah.
Yes.
They'll be fighting with each other.
Yeah. Disconnect from that one. Connect to Bust on Raspberry. You can try. You can try doing a ping before trying to connect. So mine is 25, and the way to automatically resolve the IP is to add the suffix .local. That will automatically resolve the IP by host name. So try this first. Ping your name, your label, .local. From who? For the Pi? Smalltalk. All lowercase. So, who needs help?
What's the name again, the first name?
Okay, this is your machine name, right?
What's my username?
Pi. Username. The username of the SSH login is user Pi, all lowercase. Password Smalltalk, all lowercase. So you see, I am usually connecting this way. Who needs help? Who needs help?
I'm on Twitter. That was my job. That's why you hired me, right?
So,
We tried two of them.
Try. You're on Windows. I think could be an issue with the
IPv4.
yeah IPv4. Yep.
How do we enable the IPv4?
So that didn't do it.
Come SNB. Come ST. You're on the network.
As far as I can tell, yes.
Maybe you have both. Could you?
What do you mean both? Isn't that the?
Yeah.
I don't know if there's anything else I can hit on that network.
Come
Is
ST.
there a configuration?
You can try. Can you see if you can ping mine, 2025 for example.
You want to ping?
Mine. It's between the
What is yours?
Camp ST by 0 25.
Number in front of it.
No, dot local. You need the dot local. No, not the 0. Without the 0.
I thought you were going to lose that. Oh, it's probably fixed now. Like I said, no.
so I am connected to the right Wi-Fi.
Camp ST P17 on dot local.
I'm just running all of your
You want to sit?
It's up and running.
No, let me just try.
That's your name. Is that the name of your machine?
I've been warned.
Give up.
Did they work for them?
Did it work?
I can get it to work.
Camp ST
I need to
PIZ,
see my fix.
PIZ15,
Oh,
and I'm connected
that's out of the
into
box.
Yeah.
What was the password?
Vast on Raspberry Wi-Fi.
I can see my small sites and units.
Let me see. Where is your? Okay, looks good. Yeah, but there's no way to know it's. Huh?
It's a dynamic IP address.
Yes.
It seems like we're fully connected. Actually, I think there's anything we got to do.
Everybody everybody could ping at least. Well, there's okay.
And it won't let me in. Maybe I can use any. My assumption is that you don't have enough DHCP.
Yeah, but
Or-
it's 20, it's small. Yeah, I mean 25, it's not a big number.
But you can have to adjust it, how the number of.
Yeah.
Actually, it's limited. And it's always, DHCP is always limited.
Yeah.
But maybe it's exhausted.
Yeah.
The router.
Yeah. But maybe if I reboot it, those who enter by IP will lose it. Okay.
Or I give me a manual.
I think it goes up to 99 if you're gonna do manual.
Okay. So those who ping, were you able to SSH? Pi? So you are already inside the Pi via SSH? Great. Perfect.
Both lowercase, all lowercase.
Password for the router was Camp Smalltalk, NA.
D?
For the router. Camp
Yes.
Smalltalk, NA.
Campus Smalltalk NA. Yes. You can. He's having the same issue. You can connect to the network.
Nah, I can't.
You don't know it. I do have employees, but wow.
You check the uppercase C, uppercase S, and
Yeah, I typed it into.
no.
Nope, don't look on it.
So if you go with VNC, you can go with Windows.
I'll follow along with it.
Okay.
VNC, as soon as I try to connect,
Yes.
the VNC server stopped.
I'm getting some.
Same problem.
I'm doing some research. Should we expect it to work?
Yeah, it should work.
Is there a password authentication?
No.
Or user authentication?
No,
There's nothing.
nothing.
That's okay. Well, you can use this. I would just.
Anyway, the VNC, well,
To get it to work, I mean, it's nice that you see it, but it's not necessary to work.
no, it's. Were someone able to get through BNC also? Work for you? Work for you? And did it work for them? You are on Windows. And you are on. You're using the default 5900 for the port? You are entering by IP or by name?
So I'm in here. Ending with number 8.
Real VNC?
So I said
Yes.
I said a ton.
Yes, I said to use real VNC.
It won't work with any other.
Yeah.
Sorry, I didn't see that.
Okay. Read the fucking
Well, just as it was too late.
yeah. Okay, guys. The ones that were having issues here with VNC, it was because of the VNC client. That's why I said try to use the real VNC because the receiver, the server here on the Pi is this one. So I know that the real VNC it's likely to work even if it's standard. You know what happens with standards. So the connecting through real VNC would be the best shot. So if you want to give it a try, right now you can connect. Cool. You can connect via VNC and you should be able to see the same I'm seeing but on your machine. So anyone succeed? Yes. You say you connect via VNC. Okay. Great. To what? To the router? Now, you may want to, this is funny, you can try to, I am on another machine, yeah. So, you can take your machine, your machine and enter on the browser to your Pi on the port 9999, and you will see a status of the Pi. Check. Enter your browser from your machine, enter either by host name or by IP, whatever it works for you, on port 9999, and you should see a nice status of your Pi. I will. You see it?
RPI monitor.
Yeah, you see it? Cool. So you can monitor your Pi that way. Friendly reminder, if I were you, before I disconnect the router at the end of the day, go to the Wi-Fi and connect to the hotel Wi-Fi. That way, if you are back to your room and you want to connect to your Pi, you will be able. Otherwise, if I don't have the router, you won't be able to connect. So if you want to experiment tonight, tomorrow, just go to the Wi-Fi, connect also to the hotel Wi-Fi, make it remember the password, etc. Yes, inside the Pi. That way, if you go to your room and you boot your Pi, it will automatically connect to that Wi-Fi. Got it? Okay. Now, I wanted to start showing a couple of things which you can follow me via a terminal. I will do that because else. Okay.
I can't get into the Wi-Fi.
Mariano, I have a second TP link. Use this and set it up.
Doesn't matter. I have done.
Okay.
Okay. Okay.
Before you leave the hotel.
And then bring the hotel home.
Mariano home with you.
No, I have, for those interested, I can show you. There's a way. This is nice. There's a way for you can extract the SD. You put it on a SD adapter. That's why I said just in case bring an adapter. I have like 10, 15. So if you need one, tell me. Then you put that on your laptop, and you will see it. You will see a partition that is mounted, which is called /boot, and there you can put a file, which you can manually type, which is very simple, and you give the Wi-Fi instructions, and then you put back your card into the Pi, and at boot time it will read that file and connect.
Or put in a monitor and
Yeah, or put a monitor, but they don't have a monitor in the hotel. There is a way. I don't want to explain because it would take me more time, but I am happy to show it to you or whoever is interested. You can extract the SD from your Pi, plug it in your laptop with an adapter, with a card adapter, or a pen drive adapter. I have one. You will see that a partition is mounted on your operation system, which is called /boot, and there you can put a file, which is called wpa_supplicant.conf, and there you specify the Wi-Fi settings, just the SSID, pa_supplicant.conf. But the file needs to have certain structure. It's very simple. But you can put the SSID and the password. Okay? And then you extract the SD, you put it back into the Pi, and the next time it boots, it will read that and it will connect. Gotcha? Okay, but I can help you to do it. Okay, so okay. So now what I wanted to show you is one example of a small demo I did with CSI, which you can see just running. You can follow me. I am going. Obviously, the keyboard doesn't work for me now. Okay. So I am going to the folder, CD Instantiations, Seaside Traffic Lights. I will make this bigger, but if you want to follow from your Pi, so I'm going to CD Instantiations, Seaside Traffic Light, and here you can see basically this. We have app folder, the source code, the binaries of Smalltalk 9.2. It's a pre-release. If you go to here, you can see all the, let's say, if you go to binary, here you can see all the binaries of the VM. So this is basically a distribution of Smalltalk, which is intended for server. So this is called server runtime distribution. It's basically a zip. It's 3 megabytes zip, something like that. You uncompress, and basically what you get is the VM and some extra needed files, just for runtime. And then on the app, here you can see I have a bash script which we are going to run now. A Smalltalk image, which is ICX. So this is a Smalltalk image and an ini configuration. So each Smalltalk image can have associated an ini file where you can configure million of different things. Okay? Now, if you see the bash, it's very simple. You can see what it does. It just says, okay, get into the app, export the variable lang to be this standard bash root. I am saying that is this, and I export the LD library path where I tell where the binaries of the VM are, and then I just call the Smalltalk VM. The Smalltalk VM is normally ES, but there is a specific binary when you are going headless that doesn't link to anything from the X libraries, and that is called ESNX. So if you are going headless, you should try to use ESNX. And then I said, okay, I pass the image as an argument and the ini files. So far, any question or it's clear? Seems easy. Okay, so let's run it. And you can see here, this is we are running Smalltalk 9.2. Okay, CSI started now. You have two ways. You can either open a web browser from the Pi, which I don't because it's a bit slow. It's this one here on the top left. But what I do is I connect from my machine. So go to your browser. I mean, run the bash if you want. And then if you go to your machine, you can see the CSI application running. The port is 777, and the slash, I will, you need to first run the remember to, and slash seaside. Let me remember. Traffic light. Sorry, traffic light. Traffic light. See, traffic light. Okay, so you should be seeing that if you connect either from inside the Pi. You see it? Woo! You see it? Okay, cool. You two? Two. Good. 4. Good. I will give you time. Try. Sorry? You walk? Ah, hey, you went to, yeah, nobody told you to do that. you click on the red, on the green button? Yeah, okay, that's on purpose. Sorry? Yeah, you click on the green?
Tell me what your idea is. Yeah, shut down.
The green click, the green crash.
The green crash, it's on purpose.
Oh, okay.
The green will crash. Yes, it's on purpose. It's really on purpose. Okay. So I will show you the yellow and the red work. You can restart it. Obviously, this is very slow because I am rendering on the same Pi. If you connect from your machine, it's faster. And if I click on the green, I will crash it. And you can see it. You can see it from here. There was a halt. And it says dumping a stack file to this file. Okay, we will see that later. Yeah. You got it? Okay. Anything? Anyone having issues? Great. Oh. Okay. Go.
So, okay.
Once you're open a terminal. CD. Instantiations.
Okay.
Slash. No, not that one. No. Go up. CD seaside traffic light. Up. CD up. No, CD seaside traffic light. Yeah, I know it's small. And there inside, go to the
app.
Up.
Okay, I thought you said app.
Sorry. I
was going back up.
Sorry. Okay. And there you see the SH.
// Okay.
Okay. It works there? It works?
So, okay, it's running, so now what's the address I type in?
The address?
Yeah, from the web browser.
The one of your Pi?
Oh, I need to do something else then.
No, just you run the bash. Okay, then from your machine, go to open your browser, go to were able to enter by hostname or port 7, yeah, the local, yes, 777, one more, slash traffic light.
With a capital T?
No, all lowercase.
Now, did that finish what it was supposed to do?
Huh?
It didn't.
No, yeah, it should be there.
It's just running, okay.
And why?
Camp, oh, TST.
Ah. Okay. Yellow, you can click on yellow, it will work, and then break it. So everybody click on the green button. Just be sure you crash it. Be sure to click on the green, okay? I am giving time. Okay? Okay, I will move on. So, you're done? It works? Okay. Let's continue. So, the other thing that I wanted to show you here, which you probably didn't notice, but you saw the CSI running and working until you click the green. That crash, but that's okay. This image, you can see if you do ls/LAH from humans, you can see the size of the files, and you can see, for example, the image is 3.5 megabytes. So this image that it's even running CSI is 3.5 megabytes. So it's really small. This is what we call on Smalltalk, we call it reduced runtime. So basically, when you are, for example, this image I developed on Windows because we have cross development tools. So this code of all these CSI I developed on Windows on a 50 megabytes image, I don't know, whatever the development image is. At one point I say, okay, I want to package this up for a different operation system, which in the case it's Unix. And it would run through a process where it would reduce the image for methods or classes that are theoretically not used because of static analysis. Sometimes the packager is wrong, and you need to say, no, don't remove me this one because you call it via perform or something. But the result is that it's a nice experience because you can develop on Windows with all the nice look and feel tooling that we have on Windows, and then you can just it's not cross compile, but you can package your application for a different operation system and very reduced. Like in this case, it's a 3 megabytes, and the one you will see from Seth, I think it's 1 megabyte or something like that. So I think that's something cool that I wanted to show. Then next step. Okay, so this is the next step. So far what we did is just run a package headless image, okay? But what if we run VS Smalltalk here completely with the IDE? So let's do that. You can do it too. We go to CD Instantiations. There you will see CD bast 92 ecap2 underscore camp. You can go there and then go to the Raspberry Pi directory. And once there, you can call abt32. This is the bash script for launching VS Smalltalk on this installation. And this, of course, it will be slow.
Can you make your font bigger there?
Where exactly?
The big screen, so we can spell.
In the terminal, yes. In the terminal, I can. Maybe the lights?
Says my display is offset.
It's better? Okay. Then I could make the I can make this one bigger too. It's better, yeah. Oops. Okay, anyone want successful? Yes? Okay, cool. So here what we, of course it's slow. Remember this is the slowest Pi, and we are running on our slower VM, so we have a much faster VM for ARM, but it's working, but it's already in progress. So we cannot ship it for the moment, but we will have a much faster VM for ARM. But you can see I have been developing actually. For example, when you need to develop the code that reads sensors or access the GPOs, you can, well, this font is a little bit small, but you can see here I am browsing object, I don't know what. You see it's responsive enough. I can look for implementers. I don't know. You can see the big list of implementers. Okay, I mean, you got it. It's just VS Smalltalk running also here. Yes, else you have to do it from, sorry, good point. You need to do it either from VNC or else from SSH, but with the X forwarding. Yeah, as you wish. I think it's easier with the VNC. Yes, this is a local manager. And in fact, it's already pre-built with some examples. For example, right here, you also have the very same seaside traffic light is here. So you can see the code, for example. Seaside, you see here the maps of seaside traffic light. So this image that we are shipping, we preload it with the code of the example that we ran before. So you can actually see that code. It's basically this app. You can see it. I don't know. Just that. Okay, anyone having issues? Okay. So, something I wanted to show you is, which I think is nice for IoT. That's why I will show it. And you can, from, did I crash? Oh yeah, I think I did. Okay, so from tools, oops. Tools, don't fit. Open debugger. You see, tools, open debugger. This opens an empty debugger. It's nothing on it. It's just a debugger empty. Okay, you see. But I can attach a dump of a stack that it's on a file. So here I can go and look for the crash that I generated with the seaside traffic light. It should be inside up. This one. This seaside 00.sdf. This is the stack dump that was generated when I click on the green button. And that happened on the Pi. Okay? For purposes of the demo, I will debug this also on the Pi. But the very same thing I'm doing here, you can do it on your development machine. So you can take your BS Smalltalk running on your laptop and attach and read the dumped stack. So I will show you once. This part is slow. I didn't have the time to see why, and there's something particularly slow. So here it's filling the stack, and obviously this is not a dead a string stack. This is really stack. You can see, for example, I will go up to the place where I got the halt. Just a few more frames, and we are there. Obviously, I'm not debugging from the Pi. I debug from my machine, but else I need to change all the time.
It's pretty snappy on the 3, so
Yeah, on the 0, it's, yeah. Okay, finally, here we are.
Yeah, where's the star?
Run out of battery?
Okay, yeah, it's a bit slow. So anyone is trying to do this or not? You're trying? Got it? Okay. So maybe I should have shown this from my machine instead of from the Pi. Anyway, I will click on any.
Even outside of Pi, this is
was interesting to me. So are you guys saying that you streamed every object during a dump?
Not every, but
Object on the stack?
yes, yes, and that's what I wanted to show exactly. You can see, for example, in this case, it's, I don't know, CSI null error handler on this method. This was the block. This was the object, so I can inspect it. And you see all the real value of the things, so I can go inspect all the. This was the request. Yeah, that's a good one. Method. You can see the method get, the URL, version, remote address. So all these are objects. I mean, this is a really debugger open on top of a dumped binary stack that happened on the Pi. So in this, again, the nicer thing is when you debug this offshore. So I just copy this file, the CSI, this one, the SDF. I just copy that to my machine, and then I debug it. And that's a live, not a live stack, but it's a debugger functionally interacted with a stack that was dumped on the Pi, and I can have access to the value of the object. That's a good question. External resources are complicated class variables that could have changed the value. Honestly, I didn't try with external resources. What?
I guess my question is, I'm not expecting an external resource.
No, but at least that it wouldn't crash. Yeah. Yeah, I would imagine that is not a problem. I know says if you try everything like that. No. No, this is 20 years old. I don't know.
This whole thing we've been doing, this whole thing that we've been doing has really gotten our knowledge, all of this great technology up, because Visual Age got to start with that a lot of this is geared towards what we're just seeing happen. So we have a ton of tools for doing these things.
I didn't know they had any sort of tools for working.
There was Tektronix oscilloscope that ran OTA Smalltalk, and it was in production for sale.
Okay, can we go to the next step? Okay, so here, if you see your Pi, one of the things that makes the Pi Zero very thin and cheap, it's also because the pin header is not soldered with the pins. You see, you just have the holes, but you don't have the physical pins soldered. You see, on the Pi 3, for example, it is soldered. I guess that's one of the reasons to make it the Pi Zero more compact and cheap and smaller. But anyway, the pins are there. So this is called GPIO, General Purpose Input-Output. This is very common, not just on the Pi, but on almost every board that we get these days, Arduino or whatever, Paralela that he brought. All of them usually have the 40 pins. Usually it's kind of standard, or at least you can manage to to make something work on the different boards. So I wanted to give you a quick introduction to this. You can write this command on your console. It's called pinout or p in out, however you want to call it. And you see it's a nice utility for you. Again, like this, if you bring your Pi to your home and you want to experiment with something, this is something useful, and it gives you some graphical display of the Pi that you are running on with some data about the processor, RAM, etc. And then it gives you a layout of the 40 pins, okay? So whenever you are trying to connect something into the pins, you will need to know where to connect, which cables to connect where. So this little tool is very helpful. You can see there are two 5 volts pins which are turning on by default. So you have 2 pins with 5 volts. That's the maximum that Raspberry Pi can output. And then you have 2, which is 3.3 volts. And then all of the rest are the GPIO numbers, and then in some places some ground, because sometimes you need to plug something and it's handy if you have the ground next to the positive. So that's why they don't put just one. They put a couple of ground. Then you can also, another useful tool is GPIO read all. For example, here I can read what the status of all the pins. So if you see here is on this column is the physical number of the pins from 1 to 40, and you can see which mode it is, because each pin has 2 modes, for reading or writing. So you can see it's in or out, in the case they're all in, and whether the voltage is turning on or not. You can see there are some that are on. This is by default. Some pins are on, some pins aren't. And then, so it was GPIO read all. If you want to try GPIO read all, and the previous was P in out. So far these are little tools from the operation system to see the layout of the pins, to see why the status, etc. So, but then you need to talk to the pins. You need to send data, or to turn it on, turn it off. And for that, there are like many different GPIO libraries to access the pins. On Smalltalk, we have wrap one of them, which is called P GPIO, something like that. It's a C library. So we wrap that on Smalltalk and we call it through FFI. So I will, if you want to experiment yourself right now, you can see that on the image that I give you, okay, I think I lost, I will reopen it. On the image that we ship it with you, you will see there is a workspace on the right, and there you can see what's our Smalltalk interface for dealing with the GPIO pins. It's a very simple, the most simple, basic scenario. But for really testing that, you will need a volt meter. So I have one, he has one. So if someone wants to experiment, you can see okay, here you can see this workspace with all the explanation on what you need to do. It explains basically that we are going to try one GPIO pin and with the ground, so you can take the voltmeter to measure, and then all you need to do is RPR GPIO wrapper new. You set the mode, which is VCM. I don't want to get into the details for this, but for those that know what it is, set warnings to false, and then I say, okay, GPIO set up pin number 17 and set it for output. And then I say, okay, now set the value, and I put it on. This is just a Boolean. So when I set it to true, then that pin will get a 3.3 volt. When I turn it off, it will have 0. So you can plug, you can play with this and then put your voltmeter on the pins, and you will see how turning on and turning off puts on and off the voltage. Again, I will be here all day long tomorrow as well. So if you want to really try it, I have the voltmeter and I have other cool stuff to try. Similarly to that, I wanted to show, because that is not too much fun, so I will show you the last thing. See if it works.
It's about to fall off now. Yes.
So anyone having issues? Do you want to make a 5 minutes break for coffee and then we come back? Yeah? Let's make a 5 minutes coffee? Okay, let's do that. And then we can see if you will see like the same look and feel, but you can see that here, I don't want to touch it too much because you can watch here, there is a physical semaphore, a physical traffic light there. And so what this one does is that when I click on the bottom, it also put the yellow on the physical seaside traffic light. So basically this is a subclass of the seaside component. We just changed the callbacks, where aside from changing the seaside state, I also change the pins. So I enable and disable the pins. And you can see this, for example, this uses 4 pins, 1 for ground and the other 3, 1 for each light. And if you see the image that I shipped, you can see also this example, there is a sub-app for the seaside traffic light GPIO, and you can see the code on how I deal with all these 4 different pins. And I think it's a nice basic example. Okay? So if you want to give it a try, it's a good starter kit, but you need to have the pins soldered. That's why I didn't draw for all of you. But anyway, this was the last thing I wanted to show you for the pins. And now I wanted to show you. Okay, Sebastian, help me cross your fingers. Okay. Okay, now.
So green star crashes in the GPIO?
Yeah.
Okay.
But the light should be on, maybe. Because I think the... sorry. Yeah. Sorry. Okay, so... Okay, so this last part of this is, I promise, is the last part of the demo. But I would like, before showing that, I would like to just say some words, because I think that's part of what the Smalltalk community is, and what the good thing of the campus Smalltalk is. I was traveling from Argentina, and I ordered this temperature sensor. So this measures temperature, and it uses a particular protocol for the GPO. So I didn't explain that, but inside the GPO pins, there are 4, 5, 6, or a few more protocols that specify how you read and write things. This particular device, it's called one-wire device. So I never experienced with a one-wire device before. So I bought this via Amazon, and while I was in the airport of Miami, I sent an email to another guy, Norbert, it was in Germany. He got one of these working with BS Smalltalk. And I told him, Norbert, could you send me the example? Oh, yeah. Boom, he sent me the code with his example to get from BS Smalltalk the temperature. Say, cool, I have that. And then I wanted to persist the temperature data on Gemstone. And we already started talking with Gemstone like a month ago or so, and they help us. And together we make the connection between VS Smalltalk and Gemstone to run over ARM. Originally, I was going to show just connecting to Gemstone, browse some classes, execute some code, and so on. But then I thought, what if I could store the temperature that I get from the sensor? So I put all the pieces together. So Norbert sent me the instructions. In the airport, I sent an email to Richard from Gemstone, and I say, Richard, how do I persist an object and read it back with the GVS from BS Smalltalk? During the afternoon, he sent me a class with all the examples and instructions. I ran it, cool, that was working. So yesterday night, we sit down, I started to make all these plugins of this and it wasn't working. We were drinking beers yesterday at 10 p.m. And Julian started to help me with that, and we were both with the voltmeter trying to see what was going on, until we discovered 2 cables were swapped, reverted. So we fixed that, and then once we fixed that, I could test Norbert code, and that worked. So I was able to get the temperature. I have Richard code where I could connect to Gemstone and persist something. So I was getting closer to what I wanted to show today. And then everybody go to sleep because it was late. And Sebastian stayed with me. We have some issues at the beginning, and then together we fix it, and we finally make it work, the whole example. So all of this story was because to me it was very nice how a particular example that I wanted to show, many people were helping. One from the United States sending me one example, the other from Germany, and 3 or 4 guys here helping me. So it was very positive and a nice feeling. So I think that's the cool things about this motor community and this kind of event. So thank you to all the guys that helped me with this. But anyway, let's run the example. I will just go to Instantiations, past ECAP, Raspberry Pi. With all this explanation, I hope it works. So what you can see here, this is the temperature sensor, which comes here. Here it has a built-in resistor and a jumper to put it high or low. And then through some cables, you have to put it on some particular pins of the GPO, okay? Once you are done with that, let me get the fonts bigger. So this is an image pretty much the same as the one that you have, with the only difference that I have gemstone loaded. I have the GVS loaded. That's it. The connector from VS Smalltalk to gemstone. So here you can see there are a couple of tools. One is to see and connect, open a session to gemstone. Here again, I was gonna show a gemstone running locally on my machine on a Linux. And gemstone say, okay, but we can prepare for you a gemstone on the cloud. So okay. And then I went into a website that I will show once I came back to my machine. And through a nice user web interface, I create an instance of a gemstone with some data. And now I am connecting to that gemstone on the cloud that they offer for me. So you can see the connection details. And you can see here the IP. I am reaching out to that. Sorry. I am reaching to that gemstone running somewhere. So I will try to log in. Wait, I need to initialize. Yep. I need to initialize this. Okay. Now I should be able to log in. Okay. Now I am inside a gemstone connection. You can do, like, for example, I can browse a class, let's say GS file, for example, and now from here I am browsing. You can see the slightly different syntax for the class definitions of VS Smalltalk. And now here I am browsing the GS file, which is on the remote gemstone. I can browse for implementers, senders, references. I can even create a workspace. So I can create a workspace and said, I don't know. Yeah, bad boy.
That's something that doesn't exist.
I don't know, whatever. Small integer. Oh well. Do you have a class that we don't have? System. Exactly. No, we do have system. Okay. Something with the UTF-8. Which one? Ah, yes. And then what do I do to that? What? CR?
No, RC bag would be not with JS file, but it's the class name.
Stands for read use config.
Okay, I just
Yeah.
couldn't. That would work. Okay, yeah. We don't have that in BS Smalltalk. So you are sure this whatever you evaluate this it's actually happening in Champstone. We don't have GS file. So this is all about tooling. You have everything. You can look for everything you can see here. Well, lot of different tool. Okay, and this is the interesting part, which I don't want to go into much details, but basically I get a gemstone session. I remove this class is the one that is taking and storing my measures. So if you browse this class, it has some simple methods like record sample, which would store this into class on the readings, and the readings is the class variable. So it's nothing. It's just a class that stores measures. So what I do here is I clear the collection on Gemstone. I'm saying session evaluate. So this thing is happening on Gemstone, and then I create some measures. So I tell one wire device fetch temperature in Celsius, and this, if you inspect this, fingers crossed. Okay, it's doing for 24.5 degrees in this moment here. Celsius, pardon, Celsius. Yeah. You can
We were doing this last night at 11 o'clock.
26. Yay! Okay. So again, this is I don't want to get into the details of that class, but it's very simple. This one, that again, this is part of our wrapper to the GPO library. So this class is not new. You can see we have a parent class, one wire device with all the necessary methods. I think what this one or this one. What's class side? Class side, yeah. So you see all this code, this is all part of our GPO wrapper. So it's not something I wrote now. And then so what I do is I take one measure together with the time, then I wait 2 seconds, I record again, I record again. And then for each of them, I say, okay, this is a new reading, so create a new reading of this value at this time and record that sample. Okay? So far, nothing strange. And then I evaluate on Gemstone the report of that. So this class understands this very simple method, which just prints what are the measures. So it goes through the readings and just prints the temperature and the time it was measured. Okay? So let me evaluate this. You can see here I am inspecting two times. Here I am inspecting what I get from gemstone because I'm doing session evaluate, and I am asking the sample report to the class, but this is happening on gemstone. Okay? And all I did so far is just add measures and then commit. And here I'm doing the report from Smalltalk. So let's do that. Maybe I could try, to see if the temperature. Huh? Yeah, ice would help. Yeah, yesterday we put it inside the beer because it's waterproof. So yeah, we have drinks with ice, so we put it there, and it was like 4. Okay, I slightly changed it, at least for one of the measures. Okay. Okay, we can do that. Yes, that's a good idea. Thank you, Donald. So I will start again. 1, 2, 3. Now try to measure. Okay. Oh yeah. Thank you, Donald. So you can see how the temperature decreased, obviously. And something which is very funny is that, remember, I opened 2 inspectors, one happening inside Smalltalk and the other one running on gemstone. And you can know that because the print string of the times are different. You see AM here, no AM here, 30 and then day and then month, and here month and then day. So it's clearly that both things were answered, one from Smalltalk and one from gemstone. And you could see how transparently you can persist something in gemstone. So that's what's everything about this demo. To conclude, I think it's a really nice architecture where you could have nice developing tools, where you could use your big development environment. Then you could potentially package that into your target operation system, make smaller images. Those smaller images could have really great debugging utilities. I show you one, which was the stack dump. Seth will show you remote debugging, which we also have. And then you can have also access to all the GPU, and finally be able to persist on a gemstone on the cloud. So I think this is a really nice architecture for IoT, and that's why I wanted, aside from the hands-on idea where I wanted everybody to go home with something working, the other thing was to show you this architecture because I think it's interesting. Okay, that's all. Yeah.
Were there some important options when you created the reduced image, the runtime image?
For this one? Yeah. No, it's the same that I use for my Seaside one. It's nothing special.
Nothing special for the Pi?
No, nothing special for the Pi. No. The only thing is, obviously, you need the VM compile for ARM, but FFA works, obviously, because I am connecting to the C library for the GPU. And you have, except the gemstone part, because we did it yesterday night, all the other part, it's on the image that we ship. so you can play as much as you want. Okay, more questions? Okay. Yes.
Is it possible that you show off this session how to use an XD environment to?
Ah, yes, that would be nice.
It would be interesting to
Yes.
see how long it takes.
Donald is going to show that.
Well, it's a 15-minute version of how to do XD this afternoon.
Awesome.
Perfect. That closes the story. Cool. Good question. Anything else? Okay.